Yo, what's up, guys? Today we're gonna be talking about something very important in the realms of physics. So you know what? Let's get started immediately because may the force be with you. Now you might be thinking it ain't even May 4th yet, you goofy. But guess what? You're the goofy one because you don't know what this shit is. That's why you're watching this video. So essentially, may the force be with you is essentially the slang term for force. And this is what we talk about today. This is the main topic for today. Force is equal to mass times acceleration. That's it. That's the whole equation we'll be focusing on today. Essentially, what this equation is saying is that force is equal to mass multiplied by acceleration. Now, guess what? The usual units for for force, are usually newtons. And fun fact, it was actually Isaac Newton that came up with this. This is why we say it's newtons, because it's named after him. And fun fact, he actually invented calculus. He invented calculus in order to better differentiate physics and what else more he had, because the math he had at the time actually wasn't enough to support his findings. So he actually had to create integral and differential calculus himself. But we're not going to be talking about that. We're going to be talking about something more simple. And so we're going to be talking about the equation F equals ma. So let's go to some examples. So let's say you had a mass of 10 kilograms, an acceleration of, 5 meters per second squared. Essentially, what you would do is you would just write down your equation, then just plug your numbers in. And your force for this one will be 50 newtons. Now, 50 newtons is just the amount of force in order to push this 10 kilogram object with 5 meters per second squared. Obviously, there's like a lot of things to factor out, such as friction, air resistance, like all those type of things. But we're not going to talk about that today. We're just going to talk about normal F equals ma stuff. Not going to go into the complex thing. This is just like a little introduction. I don't want to do my coding homework. So let's go to something else. Let's say you had, a force of 1,000 newtons. And your acceleration was, 10 meters per second squared. What would be the mass of the object that you're doing this to? Essentially, what you could do is that since it's an equation, F equals ma, you can actually just rewrite everything in order to solve for the specific variable you're trying to solve for. For example, we have F equals ma, which is solving for F. But we can also rearrange this equation to also solve for mass. Or you can rearrange it to also solve for acceleration. So you have 3 types of things that you can do in order to solve for each specific variable, which is kind of cool actually, because it gives us a chance to not only use this equation for force itself, but also for other things, which is what scientists do on the daily. Let's get back to what we're trying to solve for. Since we're trying to solve for mass, what I'm going to do is use the second equation that I've come up with, F over A is equal to M. So what I'm going to do here is just plug in my numbers. From here, we can see that the mass for this to be pushed at 10 meters per second squared with a force of 1,000 newtons has to be 100 kilograms. Or for my American audience, around there, roughly 228 pounds. Reason why we use metrics is because metric is so much better than imperial. Please use metric. Metric is so much better. So obviously now we can solve for acceleration. So let's say you had a force of 10,000 newtons. And your mass was 50 kilograms. What would the acceleration of this object be going to? So we have F equals ma. So then we can solve for m by using algebra. F over m is equal to a. So then 10,000 over 50 is equal to acceleration. Cancel out the zeros. So then our acceleration for this object is going to be 200 meters per second squared. And you have to realize something else, that with the numbers, your answer also has to make sense. You see, with 10,000 newtons and 50 kilograms, we should have a huge acceleration since we're pushing a lot of force onto this object, and it's roughly not even that heavy. 50 kgs are roughly around 110 pounds. I'm sure you've pushed your friend that's 110 pounds very, very far before. Not 200 meters per second squared acceleration far, but I'm sure you've pushed them a lot. So there's so many other things we can do with the equation, such as finding out if it's a proportional relationship or not to each other. The reason why I say this is because I was helping out my sister. I'm not calling anyone out, but you know, like type shit. But essentially, what we have here is that we have F equals ma, and then from here we can say that as acceleration increases, we can also say that force increases, which means that acceleration and force have a direct relationship. We can also say that F and m also have the same relationship, since if you increase mass, you also increase force. So both m and a have a direct relationship with F. However, m and a have an inverse relationship. This means that as one goes up, one must come down in order to make the constant true. And this is what I mean. Let's say you had a force of 1,000 newtons. This is your general force. And then let's say that for whatever reason, you have two cars. Car 1 has a mass of 100 kilograms, and car 2 has a mass of 200 kilograms. And you're going to see why this is important. Let's find the acceleration of both cars, shall we? We have F equals ma, so then we can just solve for acceleration by doing F over m. From here, let's find the acceleration. So for car 1, it's going to be 1,000 newtons over 100 kilograms, which is equal to 10 meters per second squared. Now let's see what the acceleration is for the second car. Since it's much heavier, I think you can already see where this is going. Notice anything? If you recognize a pattern, that's good, because you should. We see that as our mass was smaller, we had more acceleration. And we see how as our mass got bigger, we got less acceleration. With a bigger mass, you need more force on it in order to have the same acceleration as you would with an object of a lesser mass. This is constant for everything in physics. Obviously, it's very, very obvious to say that it's a lot easier to push something that's less of mass than something that's more of mass. But this is how you can prove it using physics and, just algebra. We can see that car 1 is significantly easier to push or significantly easier to run since it has less matter in it. While car 2, we will need to have more force on it in order to push it more since it has more mass. Now, that's essentially the whole idea with F equals ma. Obviously, there's crazy things out there with F equals ma since it goes into so much more detail. But this is just, a little introduction to what F equals ma is. So if you like the video, share, like, subscribe. Please, I'm broke. I need monies. Thank you for watching, though. Goodbye.